video, I'm going to talk about the third example of solving for the questions of inscribed angles. And if I review inscribed angles, they're the angles formed by the two lines, but each point should lie on the circumference of the circle. So the question is, the circle is centered in point B. So our midpoint of the circle should be the point B here. And points AC and D lie on its circumference. If angle ABC is 46 degrees, measures 46 degrees, we can say it is 46 degrees. And what does angle ADC measure? What does angle ADC measure? So we want to find the angle ADC. There are a lot of ways of approaching this question, but at first I'm gonna draw a diameter. So like in this way, and we can say that the reason why I draw a diameter is because I just want to split the triangles a little bit in order to find more information about it. And this is our angle D right over here, not here. So we can say that this line just across the half of the angle CBA, which means this one angle we're gonna be half of the 46 degrees. Also, according to a line, so if there is a line right over here, you were gonna be 180 degrees. So we're gonna 180 degrees. But if you see it carefully, 180 degrees should be equal to the angle half of the CBA plus the angle CBT. So that should be equal to half of the 46 is 23 degrees plus the this angle right here CBD, which is unknown. So CBD, and we can CBD, and we can subtract 23 to the both side in order to isolate CBD in the right side. And we get the 23 degrees we're going to cancel out in the right side. So 180 degrees minus 23 degrees we're going to be equal to, let's see, 157 degrees, and that should be equal to the angle CBD. So this angle right over here, it is 157 degrees. But if you look at this carefully, this angle and this angle are same. And also the lines are the same. The reason is because they are the radius of the circle. And whenever we expand the radius into other places, the angle and the lengths of lines were gonna be same. So we can say that the addition of the total angles, so addition of the total angle, which we're going to be 180 degrees, should be equal to this angle right here, CBD, which we're going to be 157 degrees, plus this angle plus this angle, but these angles, how can I say it? These angles are same, so we can just plot into D instead of C. So we can say that D plus D, which we're going to be 2D degrees. And we can subtract 157 to the both side. And we will get in the right side, 157 we're going to cancel out, and 2D we're going to leave. And that should be equal to 180 degrees minus 157 degrees, which we're going to be 23 degrees. And if we're going to be, is it right? So 23 degrees, yes. And if we divide 2 to the both side, we're gonna get, so 2 we're gonna cancel out, and it we're gonna be D should be equal to 23 divided by 2, which we're gonna be 12.5 degrees. But we're not done yet. This is half the angle of the ADC, so we need to multiply 2 to get the real angle, which means the angle D, it is half of the angle D. I'll just write it down. and that should be equal to 2 times 12.5, which we're gonna be 23 degrees. We just found the angle of the D. And this was the third example of finding the angles, inscribed angles in the circle. And in the next video, I'm going to talk about the last example of solving for the inscribed angles.